Our final type of reaction is called a double displacement reaction. This is basically where our cations and anions in two ionic compounds will swap partners. And so in this case, AB plus CD forms AB plus CB. So metal A and metal C, cation A, cation C will swap partners. Okay. Remember, they're positives. C and B and D are negative anions. Okay, for there to be a net reaction, for us to see a reaction occur, we have to have three things that drive the reaction forward or pull it forward. We either have to have a precipitate or solid form, we have to form a gas, or we have to form water. So these form our three types of double displacement reactions. Okay, so if we look at this first example, where I have lead nitrate plus potassium iodide, if I mix them together, I see that the solid lead iodide would form. And so this would be the factor that pulls my reaction forward. And then we have to remember to balance. In our second reaction, we have acetic acid with sodium carbonate. And at first it looks like there's no reaction, but I do have a solid in my it's one of my reactants. I have both things are aqueous in my products, so it would lead me to believe that maybe there's no reaction, but my carbonic acid will undergo a decomposition reaction into carbon dioxide and water. First type of double displacement reaction is one that produces water. And these are also known as neutralization reactions. And they involve the reaction between an acid and a base, and they form a salt or an ionic compound and water. So for example, I can have nitric acid react with potassium hydroxide, and so my cations will swap partners, and I'll get potassium nitrate and water, because remember my water is HOH. Our second type of double displacement reaction is one that produces gases. Okay? And generally, there are a couple. We'll focus on two mainly. And the production of a gas usually results from a second reaction occurring right away, which is a decomposition reaction. Okay, so for example, I can have an acid plus any carbonate-containing compound, and it would give me a salt plus carbonic acid, and my carbonic acid would then decompose into carbon dioxide and water. So we have an example here of sulfuric acid plus sodium carbonate, and we can see right away that our carbonic acid decomposes into carbon dioxide and water. Our second double displacement reaction that produces a gas that we'll be required to know is any compound with ammonia reacting with a hydroxide compound. We'll get ammonium hydroxide plus a salt, and my ammonium hydroxide will decompose into a gas right away. Okay, and so we can see here that the ammonium hydroxide decomposes into ammonia gas and water. Our final type is one that produces a precipitate or solid. Okay, and so up to this point, we've dealt with the fact that all ionic compounds are aqueous, but in this case, we're seeing an ionic compound that's solid. So it turns out that some ionic compounds are insoluble in water or slightly soluble. They only dissolve a tiny bit. Well, the way that we can determine this is by using a solubility table. So here we have a solubility table, and we can look at this reaction. And when we look at this reaction, we want to look at each of the things on it. So I would have a potential double displacement reaction. And so the first thing I would do is I can look, my chart lists my anions here, and then it tells us what it does with different cations. So if I look at the anion nitrate, and I come to my chart, okay, and I find nitrate, I can see that it's soluble with pretty much everything. In fact, nitrates are soluble with all things. The other thing we can notice is that my alkali metals, my group 1 metals, are soluble with pretty much all anions. So as a result, what this does is this allows me to say that my potassium nitrate is aqueous. Okay, and so now I want to look at my copper 2 iodide. So I'm going to look at the iodide. I'm going to come to my chart, find iodide, and I'm going to look and see, oh, I have copper here. Oh, but that's copper 1. So copper 2 would fit into the all others category, and that tells me that it's soluble. So since it's soluble, that means it's aqueous, and so now everything is aqueous. So in this case, I'd say there's no net reaction. So let's take a look at a second example. We have a aqueous solution of acetic acid reacting with an aqueous solution of sodium carbonate. We can have our double displacement reaction occur. And again, here we can see I have a group 1 metal, so that should tell us right away that that is aqueous. And then here, most acids are aqueous, but if I look under carbonate, I can see that my proton is soluble, so that would be aqueous. So again, this would lead me to no reaction, but then we remember that my carbonic acid will break down into H2O and C2O. So I have iron 2 nitrate reacting with sodium hydroxide. So we can have our substitutions. Okay. Here I have a group 1 metal. So I know that all elements with group 1 metals are aqueous. So now I want to look at my sodium hydroxide. So I'm going to look under hydroxide on my table, and I'm going to look and see that iron 2 fits in this all others category, which means that it has a low solubility. So that tells me that iron 2 hydroxide is insoluble in water, so its state would be solid. So therefore, I would state that it's solid here, and I would get a precipitate with this reaction.